In this video, we'll be looking at how to use the first derivative to find the relative extrema of a function. If the derivative changes from negative to positive at some value c, then f of c is a relative minimum of f. Now recall that f prime is the slope of the tangent line. So if I have a tangent line that's got a negative slope, and then a tangent line that's got a positive slope, my point C would be a relative minimum. Now if the derivative changes from positive to negative, so from positive to negative, then f of c is a relative maximum, so f. And if the derivative does not change sign at c, then f of c is neither a relative minimum nor a relative max. Right? On an example that we'll be doing, we're asked to find the relative extrema of the function f of x equals 1/2 x minus sine x in the interval from 0 to 2 pi. Our first step is to locate the critical numbers. And we'll do that by finding the derivative and set it equal to 0. So f prime will be 1/2 minus cosine x. If we set this equal to 0, we have move my cosine to the left. So I need to find angles that have a cosine of 1/2. Let me draw my reference triangles. Cosine is defined as adjacent over hypotenuse. So my adjacent side is 1 and my hypotenuse is 2. The cosine is also positive in quadrant 4. Alright, my angle then, my reference angle is going to be pi over 3. So x equals pi over 3. And then all the way around, 1 pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3, 5 pi over 3. These are my critical numbers. Now these critical numbers determine the intervals. So I'm going to draw my number line. My interval that I'm working with is from 0 to 2 pi. So I can label those endpoints as 0 and 2 pi. And then I have pi over 3, and I have 5 pi over 3. So I'm dealing with this interval from 0 to pi over 3, this interval from pi over 3 to 5 pi over 3, and this interval from 5 pi over 3 to 2 pi. Now what I want to do is pick test values. So a test value in this interval, we could use pi over 6. You can use any value you wish as long as it's in this interval. In this one, let's use pi. And in this one, let's use 11 pi over 6. Now what I want to do with those test values is I want to see what the sign of the derivative is at each of those test values. And that'll be the sign of the derivative in that entire interval. So on this one, let's go f prime pi over 6 and indicate that one. Let me write this also, pi, and then f prime of 11 pi over 6. Alright, I need to enter my derivative. 1/2 minus cosine x. And then my first test value was pi over 6. I'll store that into my calculator. And looks like we're getting a negative 0.366. And let's store pi. $1.5. And then let's store 11 pi over 6. Right now, this derivative is negative. This derivative is positive. So we have something that's going like this. That means that at this point, we have a min. On this left side of our critical number here, I have a positive derivative. On the right side, I have a negative. So this point is going to be a max. Now when we give our min and max, we give the ordered pair. F of x is 1/2 x minus sine x. So f of pi over 3 is going to be 1/2 times pi over 3 minus the sine of pi over 3 and this is pi over 6 minus, and then the sine of pi over 3 looks like root 3 over 2. So we're going to need a common denominator here. Multiply by 3. So pi minus 3 root 3 all over 6. I have a relative minimum at pi over 3, pi minus 3 root 3 over 6. Let's do the same thing for my other point here. F of 5 pi over 3 is going to be 1/2 times 5 pi over 3 minus the sine of 5 pi over 3. This is 5 pi over 6 minus this is a negative root 3. So the sine is going to be a negative root 3 over 2. And I'll need to get a common denominator again. Multiply by 3. So I have 5 pi plus 3 root 3 over 6. So I would state then that I have a relative max at 5 pi over 3 and 5 pi plus 3 root 3 over 6.